Hey everybody, here's the video that I told you I was going to share with you. Um, if you want to take notes, I highly recommend doing that. I'm going to try and keep this short. We're just going to take a little bit of notes to explain what's going on, and then we're also going to do one practice problem. When you show up to class on Monday, we're just going to be practicing this stuff. So I'm not really going to go over the rules, how it works here, because that's what I want you to follow along and digest. So feel free to pause, feel free to rewind, make sure it makes sense to you. But here we go. So we're talking about graphing, linear, not equations, but inequalities. So just like we've solved equations and solved inequalities earlier this year, now we're going to learn about graphing inequalities. Just like solving, graphing inequalities is exactly the same as equations. So we do the exact same steps to get things lined up. We like having it in slope-intercept form. All of that is exactly the same as equations. But I need you to know that there are two exceptions to this. Okay? So everything is going to be the same. We want to find the y-intercept. We want to find the slope. And then after we've found all of that by doing what we would normally do, we've got to keep these two exceptions in mind. First of all, is the line itself going to be solid or dotted? And the way we determine if it's a solid line, like we're used to doing, or a dotted line, which is a little bit different, solid lines are whenever we have an inequality with the equal to. The dotted line is anytime it's less than or greater than. Then it would be a dotted line. And that's just the same as when we have a filled-in circle is equal to, and an open circle is just less than or greater than. So it's the same idea, it's just with the line that we draw. A solid line is what we are used to drawing for all of our equations, because equations are equal to. And if there's no equal to, then we would do a dotted line. All right, the other exception is that whenever we're graphing an inequality, we will be shading one side of the line, okay? And to figure out which side, so if you've got a line like this, we're either going to be shading down here or up here, one or the other, because all of those points that are shaded would work for that inequality. So how do we figure out which side? Well, very simply, we pick a point that's on one side or the other. Just pick an easy point. Usually 0, 0 is a great one to pick as long as it's clearly on one side or the other. And if that point works, we shade the side that that point is on. So if it's here and we pick a point that's somewhere up here and it works, we would shade up here. If we pick a point up here and it doesn't work when we plug it into the original inequality, if that doesn't work up here, then we would shade everything down here on this side. Because what we're saying is that for the shading, every point that's shaded would work in that original inequality, every ordered pair. So that's what you're showing, is that there are an infinite number of possibilities. So let's do an actual practice problem. So I just made up a problem. And what I came up with when I was just writing it down was 4x plus 10y is greater than 20. Now, before we get started on this, let's think of what ways we know for graphing. What do we know? We could rearrange this and put it in slope-intercept form, and then we would just have the y-intercept. We could then use the slope to find two more points and graph the line. Or we could think back, wasn't there one option that we only needed 2 points? And I looked at this problem and I was like, hey, if we graph using intercepts, we could do this by just finding the x-intercept and the y-intercept, just those 2 points, and then we could draw our line. So I figured, let's do the easy way. Let's just do 2 points. Because these numbers, I also noticed, these numbers are going to be pretty easy to find the x and y intercepts. Okay, So the x-intercept is found by making y 0, and we'll put an answer here in a second. The y-intercept is found by making x 0. So that's how I get 5 and 2. So if you need to pause that and think for a second, how did I get 5, how did I get 2? Feel free, but hopefully you'll understand how I got those two numbers. Now, what I need to do is I need to draw my axes, there they are, and I put my y-intercept of 2 and my x-intercept of 5. And now, before we draw the line, normally, now is where we would line up our ruler, we would take a pencil, and we would draw our line. But I told you there's two exceptions. The first exception is it a solid or a dotted line? So we just look right here. There is no equal to, so that means it needs to be a dotted line. So we would draw a dotted line. I do my best to make it straight here. It's a little wobbly, but you get the point. So that would be the first exception, is that this would be a dotted line. The second thing that's different is we have to figure out which side to shade. So I thought it'd be a good idea to pick an easy point like 0, 0 right here. And then we just plug in 0 for x and 0 for y. And we say, okay, 4 times 0, 0, plus 10 times 0, 0, 0 plus 0, 0. Is 0 greater than 20? No. So that means this point doesn't work, which means none of the points down here work. So where do the points work? They work on the other side of the line. So you'll see I'm going to shade in the top of this line, representing all of the points that will work. Every point that's covered by this shading, that ordered pair, wherever you are, plug it in for x and y, and it will work. So that's how we do graphing linear inequalities. That's all I've got for you today. I made it even shorter than I was hoping, so that's great. Just over 7 minutes. Hopefully you enjoy your weekend, and I'll see you in class on Monday where we're going to practice more of these and answer questions you might have. See ya!